So the identities that you need to know, you already know some of them. For example, the reciprocal identities, you already know. The ones that are called the reciprocal identities, because you know that sine is the reciprocal of cosecant. So cosecant is 1 divided by sine, and sine is 1 divided by cosecant. That's what it means to be reciprocals, 1 over. All right, those you already know. There are also a group of identities called the co-function identities. Now, you are very well aware that we have sine and cosine. We have tangent and cotangent, and we have secant and cosecant. Those are called the co-function relationships. Sine and cosine have a co-function relationship. They're not reciprocals. That's a different setup. Co-functions mean this. Take your calculator out, put it in degrees. That would be everybody. Take your calculator out, put it in degrees, type sine 40, and then type cosine 50, and tell me what happens. Yeah, I mean, 2 separate problems. I want you to type in sine 40, get an answer. Type in cosine 50, get an answer. What about those 2 answers? They're the same. All right, let's try this. Type in sine 10, type in cosine 80. They're the same. Now, what's the relationship between the first 2 angles I used, 40 and 50, and the second 2 angles I used, 1 and 80? What are they? Well, what do we call angles that add up to 90? Complementary angles. Complementary, CO, co-functions. What it means to be a co-function is, it means the sine is equal to the cosine of the complement. So when you see those identities, remember complementary co-functions. When you see 90 minus x, you think complementary. That's complementary. That's a co-function. So when I say something like, what's the tangent of 90 minus x? You're going to see 90 minus x, think, oh, complementary co-function. What's the co-function for tangent? Cotangent. So, okay, so the cosecant of 90 minus x is what? Well, the cosecant is the complement, complement of what? Secant. Those are the co-functions, the ones that involve the complementary piece, 90 minus x. Those are the co-functions. You have to have those memorized too, but they're easy. 90 minus x, complementary co. Secant, cosecant. Tangent, cotangent, sine, cosine. Then there are a group of identities called the quotient identities. These are hugely important. Tangent is sine over cosine. Oh my gosh, this eraser says. Let me, Marty, let me write you a pass back to resource. I didn't email her, so I'll just write you a pass. All right, so the identity is tangent equals sine over cosine. That one you are going to use every day. Every day, probably more than once a day. We use it all the time. It's called a quotient identity. The quotient of the sine and the cosine is the tangent. Did you get everything?
Yeah.
All right, there's another one with that, of course. If tangent is sine over cosine, then cotangent is cosine over sine. So as you're walking along through your problems, if you run into a situation where you have sine over cosine, you can immediately change that to tangent. Or if you have a tangent, you can immediately change it to sine over cosine. All right, that's easy. Now, you also have a group of identities, also very, very important, called the Pythagorean identities. So I'm going to put my triangle up here. Does that triangle make sense to everybody? I'm going to call that R because I'm envisioning a big circle here. Does that make sense to everybody? That triangle over X up Y, central angles, theta, radius, okay. Would you agree in that triangle that X squared plus Y squared equals R squared? Is that a true statement?
Yes.
Yes. I'm going to divide everything by R squared. So I have X squared over R squared, Y squared over R squared equal to 1. True statement? Then I'm going to rewrite this as X over R quantity squared plus Y over R quantity squared equal to 1. But wait a minute. What's X over R? That's cosine. So what this really says is cosine squared plus sine squared equals 1. Now, where did that come from? That came right from the Pythagorean theorem, hence it's called a Pythagorean identity. Now, there are literally, I'm not making this up, millions of trigonometric identities. This one is called the fundamental trigonometric identity. What does that tell you about its importance? Very. This is the biggie. Okay? This is really useful. You're going to use it over and over again. But this one unlocks a ton of calculus problems for you, trigonometric proofs for you. This one is very, very important. Now, if you're looking at the box in the book or on the green sheet, there are other identities listed as Pythagorean, right? I mean, it's not just this one. Those other ones come from this one. So if I divide everything, let's say, by, I don't know, cosine squared, then what does this say now? I took my fundamental trigonometric identity and I divided everything by cosine squared. So what do I have? 1 plus, okay, sine over cosine, which is tangent. So 1 plus tangent squared equals, all right, what's 1 over cosine? What's the reciprocal of cosine? Secant squared. So that's one that's also listed, isn't it? But it is just a different version of the big one. What do you think is going to happen if instead of dividing everything by cosine squared, I divided everything by sine squared? What do you think is going to happen? Look at your green sheet. It's going to be 1 plus cotangent squared equals cosecant squared. Now, one thing I forget sometimes that is so old hat for me. When I square a trigonometric function, I can write it like that. You can absolutely write it like that. We don't, because we don't want to mess around with those parentheses, so we write it like this. These two things mean exactly the same thing. This is the way we write. Generally, this is the way we write a squared function. If you want to write it this way, it's perfectly okay. But don't you dare write it this way. Do you see why? This looks like we're squaring the x, and that is not what we're doing. We are squaring the sine. Everybody got it? Okay, so you can either use the parentheses, you can write it the way we normally write it, but don't write it this way. All right, so let's see, what have I talked about? I talked about the reciprocal identities, which you already know. We've done the Pythagorean, we've done the quotient, we've done the cofunction. Oh, there's one more group. What's the group? The odd and even ones. Now, what it means to be odd and even, take your calculator out and do this for me. Type sine 30 and then type sine negative 30. All right, now type cosine 30 and cosine negative 30. Now tell me what you observe. What about the two sine numbers? One was positive and one was negative. So in other words, when you inputted a negative to the sine, when you did sine negative 30, you outputted a negative. You put a negative in, you get a negative out. What happened with the cosine? When you input the negative, it didn't matter. You got the same answer back again, didn't you? That's the difference between an odd and an even function. In odd functions, negative in means negative out. So in other words, odd functions, the sign of a negative is the negative sign. So you put a negative in, you're going to get a negative out. That's what it means to be an odd function. An even function says, go ahead and put a negative in. It's not going to make any difference at all. The negative has no impact in an even function. Odd. There are only two functions that are even. Everything else is odd. The two that are even are obviously cosine and secant. Cosine and its reciprocal are even. So what does it mean to be even? It means put a negative in and it's gone. Negatives disappear. They're irrelevant. All of the other four functions, sine, tan, cotan, cosecant, are odd, which means if you put a negative in, you're going to get a negative answer. So the sine of negative 240 is going to be negative sine 240. Got it? So when as you're memorizing, you understand what even and odd means. There are only two functions that are even. So that's what you need to memorize. Cosine and secant are even. They're the only ones. So everything else behaves this way. So we take our quiz, and I say, what's this equal? You're going to say, wait a minute. The only ones that are even are cosine and secant. So this guy must be odd. And odd means negative in, negative out. Got it? So those are the groups. Oh, look at that green sheet. There are lots more identities, right? And we're going to work our way through them. But right now, those are the ones you're responsible for. Everybody clear on that? Michael Bammer? Now, let's look in our book at a few homework problems. Valerie?
I thought you just said that sine and cosecant are the only ones that produce.
Cosine and secant are the even functions. Everybody else is negative in, negative out. Okay. So I don't know what I said. What I should have said was cosine and secant are the only ones that behave this way. Okay. Everything else is negative in, negative out. So I'm sorry if I said that wrong. That's how I should have said it. Cosine and secant are even. Everything else is odd. Yeah, so I'm getting ready to do a couple of homework problems just to show you how we're going to use the things that we are memorizing. I am on page 451. All right, so on page 451 and 5.1 and 5.2, our task is going to be basically to simplify and prove these trigonometric statements. So, in order to do that, many times you're going to have to factor. So you're gonna have to factor things that have sines and tangents and all that in it. So the guy that wrote your book decided that you might need a little factoring practice. So I've assigned 5, 6, 7, and 8 in the quick review, but I'm not going to do all these, but I'm going to do the first one just to kind of show you what's going on. You have factored for many, many years in your life. If you're starting a new sheet of paper, that's great. This is the first homework problem. We're going to leave some space for these because you're going to come back and do these on your own. But we're going to do this one. All you have to do is factor it. Because next time you see that problem, it might look like this. And you need to make the correlation. You need to understand this problem is exactly the same as that one. And however you would factor this is how you would factor this. Okay? So how would we factor this? Yeah, it's been a while, like 7th grade.
Would it be, it would be A minus B?
He's right. That's it. That's all there is to it. Because when you FOIL this, don't you take this times this to get the first term? That's how you get A squared. When you take this times this, you get your last term, right? That's B squared. And when you do the outsides and the insides, you would get a negative AB and a negative AB, which would give you a negative 2AB. Now what that means then is, this guy is factorable. This one isn't. I'm just showing you why we are practicing factoring, so that we can do this. What would this one be? Sine minus cosine. Exactly. And then hopefully there's some kind of denominator here, and you'll be able to cancel, and it'll work out beautifully. All right, so these first few problems are you're just practicing factoring, because you're going to use them in these later problems. So leave some space, go back and fill in 6, 7, and 8 on your own, and let's skip down to number 9. Number 9 says simplify tan cosine. Now, I will always say tan and cosine. I will never write that without the x. Please make sure you have an x, a theta, an a, whatever letter you want, make sure it's attached. TAN all by itself is something you get in Florida. It has no use in math class, okay? No use. TAN, SIN is in theology, has no use in math class. Attach an angle every time, okay? So I will say tan, I will write tan x. All right. So, what do you think? Your job is to simplify that. What do you think? Think about your identities. What's the one I told you you would use every single day? It was the quotient identity that says tangent is sine over cosine. So step 1, sine over cosine. What happens? The cosines cancel. This is a multiplication problem. Don't the cosines cancel? So what does that simplify down to? Just sine. Just sine. Let's look at the next one. That was number 9. 10 is cotan tan.
So same thing.
Could we do, Brenton says, let's do the same thing. So what's cotangent? Cosine over sine, perfect. What's tangent? Sine over cosine. Oh boy, what happens this time? It's just 1. Now, does that make sense to you? Go back and look at the original problem. Does it make sense to you that the answer would be 1? Why? They're reciprocals. So when we recognize that, when we see a cotan times a tan, we don't need to do this. We can. It isn't wrong. But by golly, what always happens when you multiply reciprocals? You always get 1. So if I'm going to multiply a cosine times a secant, it's going to be 1 every time. You don't need to show any work. That's kind of an automatic. All right, number 11. Looks scary. I'm going to change the pi over 2 to a 90. Is that okay?
Yeah. Because you're changing it into theories and stuff.
Yeah. And pi over 2, that's an easy one for me, right? 180 over 2. So I'm going to do it in degrees instead of radians. I don't care. You can leave it radians if you want. Now, let's look at this for a minute. I see a 90 minus y. What do I immediately think? Complementary. Which makes me think co. What is the co-function for sine? Cosine. So I have secant. Oh my gosh. We just talked about this. That is cosine. We have an identity for that. I'm trying to help you not have to memorize so much. 90 minus y, complementary, CO, co-function. Co-function for sine is cosine. What happens when I multiply a secant and a cosine?
1.
I get 1 because secant and cosine are reciprocals. That's your reciprocal identity, but you already know that one. You'll get that one memorized. These aren't so bad. Cotan sine. Doesn't matter what letter you use, just a variable. I'm using ones they use in the book, it's you. What do you think about that? It's cosine over sine. And it's times sine over 1.
So that's just going to be cosine.
So that's just going to be cosine, as Brenton says, and he is correct.
Just one other
Yep.
question. How do you get from the sine 90 minus y to the cosine?
Okay, look at your green sheet or look in your book under where it says co-function identities.
Yes.
And what does it say about sine 90? That might say pi over 2.
Yeah.
Pi over 2 minus x. What does it say about the sine of pi over 2 minus x?
You set to know that it equals that.
Yeah. Yeah, that's why you memorize those. Those are the things you have to memorize. Okay? Yep. But I'm trying to help you. 90 minus means complementary. That's a co-function. So, I don't know. One way or the other, you got to know it. All right, let's look at 13, Scary. Now, I have 2 huge advantages. I'm 58 years old. I've been doing this for 36 years, plus before that. So, I just know this stuff. But I also totally love it. I totally love this. One of my favorite things to do is prove trigonometric things. I totally love it. It just makes me happy. This and vectors just make me happy. Exactly. So when I look at this, I see 1 plus tangent squared, and little bells go off in my brain. Ding, 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 ding. Because what's 1 plus tangent squared? Secant squared. I know that because I memorized my identities, right? So every time I see a 1 plus tangent squared, I can replace it with secant squared. Now, what is secant squared? It's the reciprocal of the cosine. So I'm going to write this as 1 over cosine squared. And then I'm going to do the same thing here. What's cosecant squared? 1 over sine squared. Now, you're thinking, Mrs. Ford, this is getting worse, not better. But no, just relax a minute. How do I divide fractions? I have a fraction divided by a fraction. I'm going to multiply by the reciprocal of this. So it's gonna be 1 over cosine squared times sine squared over 1. Which gives me what?
Tangent.
It gives me sine squared over cosine squared, which is tangent squared, because sine over cosine is tangent. So this is what we started with. We had to go through some steps, but ultimately, all that mess just came down to tangent squared.
Does tangent need to be squared?
Yes, that's what that is right there, it's supposed to be.
So you just broke it down?
Yep, broke it down and ripped it apart.
What's your favorite?
All right, now I'm going to look at 14, and then I'm going to start skipping around a little bit. Or maybe not. Maybe I'll just finish this whole section for you. There's only a couple left. I could do this all day. This is so fun. All right, so here's where we are. Now, when I see a square, all right, back up. When I erased it, but when I have a 90 in my problem, I automatically think complementary cofunction when I see that 90. What group do I think about when I see a square? The Pythagorean identities. Now, there is no identity that says 1 minus cosine squared. There is one that says 1 plus tangent squared, and that's why I was able to do that. However, there is an identity that says sine squared plus cosine squared is 1. What if I rearrange this identity? What if I move the cosine squared to the other side? Then it would say sine squared equals 1 minus cosine squared. Now, it's the same identity. Everybody agree with that? All I did was rearrange it so that I could come over here and replace 1 minus cosine squared with, so now I have sine squared theta over sine. What's going to happen when I have sine squared over sine? One of them is going to cancel, and I'm going to be left with sine. Just like when you have x squared over x, isn't that x? Sine squared over sine is just sine. So that problem that we started with simplified down to sine. All right? Cosine minus cosine cubed. All right, anybody have an idea what you might do? Your job is to simplify this. Do you have an idea what you might do to get this ball rolling? What was the very first problem I did today? Factoring. Does that factor at all?
Yes.
What can you do to factor that? Take out a cosine. So if we take out a cosine, don't forget the placeholder, you'll be left with 1 minus, there go those bells again, ding, 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 ding. What's 1 minus cosine squared? Sine squared. We just figured that out. We just figured that out, didn't we? 1 minus cosine squared is sine squared. So now I've got cosine times sine squared. Now there are some other things I could do, but none of them would be necessarily simplifying, so we'll just stop right there. There isn't really any more canceling out I can do or shrinking of the problem. That's as simple as it gets.
So what do we use these for?
What do we use this for? Oh, in the big scheme of life, there probably aren't a whole lot of applications of trigonometric proofs. However, these substitutions, like taking out a 1 minus cosine squared and replacing it with sine squared, those are used all the time in the calculus. And like when you look at the Pythagorean identities, and it says 1 plus tangent squared is secant squared, when you learn how to find the derivatives and the integrals, I know, but when you learn how to do that, those identities come into play. Secant and tangent are linked. For example, the derivative of the secant is secant tangent. Okay? I mean, it just is. The derivative of the tangent is secant squared. They're just tied together all the time. I do with my juniors. When you guys are gone. When the seniors leave, that's what the juniors is.
Some of them can be fun.
Yes. You probably weren't doing trigonometric ones. You were probably doing just regular polynomials. Maybe, I don't know.
I don't know.
All right, one more. Oh my gosh, look at this guy. Oh my goodness. Your job is to simplify this, okay? So, anybody see anything? I got bells going off in my head like you would not
You
believe.
get the sine squared to the right.
What about those two right there?
Those are reciprocal.
Those equal tangent.
Sine squared plus cosine squared. That's one. That's one. That's your Pythagorean identity. Sine squared plus cosine squared equals 1.
So it's just tangent.
So now, no, I have 1 plus tangent squared over secant. Ding, 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 ding. What's 1 plus tangent squared?
Secant squared.
Secant squared. So now I've got secant squared over secant,
So it's just gonna be C.
which just reduces to secant. So who in the world would have thought that? When you look at that big thing, it all boils very simply down to secant. And if I'm a calculus student and my teacher gives me this problem that's an integral symbol, to integrate that, no way. But integrating this, easy. Okay? That's why we do it. This is a pre-calculus class. We're learning skills to prepare us for calculus. Okay, so that's easy enough. Now, let's see what else I've got picked out here for you. I'm going to skip a little bit. I don't know if you every single one. I'm going to skip to problem number 51.
Yeah, I know.
All right, so I have skipped to problem 51, which is not a simplification, although I will use some of those tools. It's an equation, and it says find all the solutions in the interval from 0 to 2 pi, and you do not need your calculator. So we're going to do this. We're going to solve this equation without our calculator. All right. What? This tells me this is the interval where I'm looking for my answers. So I'm looking for my answers between 0 and 2 pi. On your test, I wrote it this way. Or instead of 2 pi, that could be a
180. 360.
right? Which tells me that where will I look for my answers? All the way around, right? Okay. So what are your thoughts when you look at that big ugly equation, which by the way is a homework problem? I'm doing another one for you. What are your thoughts when you look at that?
Take out cosine.
Could you factor first?
Yeah.
He says, could I take out a cosine? And I certainly can. And what would I have left? 2 sine minus 1. Don't forget the minus 1. It's like everything else. If you factor out the whole thing, you have to put a 1 in there to hold that place. Now, think about solving a regular equation. What do you do after you get it factored? Set each piece equal to 0. So cosine equals 0, or 2 sine minus 1 equals 0. Now, this kind of problem we've done. This was on your test. Very simple little equation. This one we've also done. You can figure this out. Remember, you're looking the whole way around. If the cosine is 0, stop and think. If the cosine is 0, it's going to have to be on an axis, isn't it? Yeah. It's not possible for me to draw a triangle where the adjacent side is 0, is it? So somewhere around the circle, there is a place where the cosine is 0. Where does it happen that the cosine is 0?
On the right or on the left? The top.
Top and bottom. Why? Because cosine is x over r. And if I want that to be 0, I have to have x being 0. Don't I? So the answers to this equation are, if I do it in degrees, 90 and 270. Cosine is x over r, x is 0 up here and down here. Now, what does this one say? We're not done. That's the first half. We still got the second half. Sine equals 1/2. All right, I can draw a triangle for that anywhere around here. Where would I have a triangle if opposite over hypotenuse has to be positive? Certainly quadrant 1 and also quadrant 2, because those are the places where y is positive. Sine is y over r. So what kind of angle, you did this before, what kind of angle has a sine of 1/2? 30 degrees. But it's also 30 over here.
So 120.
Not 120. 150. Stop and think. This angle, I don't know what it is, but I know this one's 180. And I know in between them is 30. So doesn't this have to be 150? So there are 4 answers to this problem. These 2 and those 2. All right, I'm going to start one more for you. We may not get it finished. But let's go ahead and do 53. Oh, Lord, this looks scary. (53) says tan sine squared equals tan.
Subtract the 10.
Very good. We want our equation to be equal to 0. Why do you want your equation equal to 0? So when you factor it, you can set each piece equal to 0. That's the only way you can do that, is if it equals 0. What you can't do, kids, and I'm so glad Brenton didn't say this, what you can't do is divide both sides by tangent. You can never divide by a variable if your purpose is to cancel it out. If you're going to cancel it out, don't do it, because you're going to lose some answers. Do not divide and cancel. All right, I'll say that again. Do not divide and cancel. Subtract, like Brenton did, and then what can you do now that you subtracted? Now you can factor. So I'll take out a tangent, and what will I be left with? Sine squared minus 1.
And then
Set an equal to 0. Now that is an identity, it's not gonna help you to use it this time, so I'm just gonna say sine squared minus 1 equals 0. Now, there's that crazy 0 again. You can't build a triangle where opposite over adjacent is 0. Does everybody understand that? Okay, so instead of building triangles, I'm gonna be looking on my circle. And I need to find a place where when I put y over x, I get 0 over 1. So where does that happen if you put y over x? Because that's what tangent is.
180, 360.
It happens here for sure, and it also happens here. So instead of saying 360, let's say 0. So 0 and 180 are the answers to this one. Y over x is 0 here and here. Not here and here. This would be undefined, right? If you did y over x. Okay, let's finish it. We're almost there. Sine squared equals 1. Right? Which means sine equals plus or minus 1. Would you agree with that? Right, where does that happen?
The square root of 1.
Well, yeah, that's how I got plus or minus 1. I square rooted it. But where does it happen that the sine, that's y over r, is 1 or negative 1? No, it doesn't happen here.
Well, like, give me.
Sine has to be y over r. So it doesn't happen here. Would it happen up here?
Oh, you get 1.
1 over 1? Yeah, so it happens there. Does it happen anywhere else? That you get 1 or negative 1? Remember, you get either 1.
Yeah.
At the bottom. Wait. I know you can't wait to get out of here. Those are extraneous roots. The only answers to the problem are right here. Why are those extraneous roots? Get your calculator out. Type in. You said the answers here were 90 and 270, and I agree totally. But type in tangent 90. It's an error, it's undefined. So the only answers to the problem are 0 and 180. Very, very tricky. Very tricky. Because you're supposed to be smart, yeah?
That's great.
All right, anybody who wants a test score, Maggie, can you turn that off? So I'm not public right now. Test scores here.
Yeah, this is where